Bloom's taxonomy is a hierarchy of models used to classify educational learning objectives in biomechanics. They are knowledge, understanding, applying, analyzing, evaluating, and creating.
The activity we will be discussing is a pirouette. A pirouette is a spin performed on one leg with a raised foot touching the knee of the supporting leg. This supporting leg is raised to the ball of the foot and the arms are raised in front of the dancer. While there are many different techniques used with different styles of dancing, the main goal is to turn as many times as possible without falling. The biomechanical concepts we will use to discuss this activity are conservation of angular momentum and rotational stability. Conservation of angular momentum is the principle that, in the absence of external torques, the total angular momentum of a given system remains constant. Angular momentum is equal to the moment of inertia times angular velocity. Rotational stability is the resistance of a body to having its rotational or angular equilibrium disrupted. One way that rotational stability is affected is the base of support. The base of support is defined as the entire area bound by a perimeter formed by the object's points of contact with a relative surface that provides a counterforce. The surface that provides the counterforce, in this case, is the floor.
The problem that we are trying to solve about this activity is determining how to turn the maximum amount of times before falling out of the pirouette. In dance class, teachers make dancers begin with straight arms, then bend their arms close to them to perform the spin. But how does this work biomechanically? According to the law of conservation of angular momentum, the moment arm of inertia times the angular velocity is equal in a given system throughout the entire motion. The two things that affect moment of inertia are mass and radius of the moment arm. Since the mass of the moment arm remains the same in this case, the moment of inertia is only affected by the radius that the arms are away from the line of center of gravity. If a dancer begins with arms extended, a high radius, then changes to bent arms, a low radius, after beginning a spin, then the system has no option but to increase the angular velocity in order to maintain the angular momentum of the system. Another rule that dance teachers enforce is that throughout the turn, the dancer's shoulders and hips must remain directly above the foot that the dancer is balancing on. This is due to the rotational stability required to remain upright and avoid falling. Since a pirouette must be performed on one leg that is raised heels off of the ground, this creates a very small base of support. The center of gravity of the dancer is also located in the middle of the base of this support. If the dancer moves her hips / center of gravity past her base of support, then the force is torque producing, and gravity acts as a disruptive force, pushing her off of her balance. If this motion happens during the turn, then the dancer will fall.
As we mentioned before, the defining success factor of a pirouette is the number of turns able to be completed before falling. Using the law of conservation of angular momentum, the angular velocity can be increased if the radius of the moment arm is changed from long to very short. In the case of a pirouette, this can be accomplished by bringing the arms close to the body once the turn has begun. Secondly, in order to prevent falling in the turn, it is necessary that the dancer's hips / center of gravity remain directly above the foot / base of support. This can be accomplished by engaging the core muscles and leg muscles of the dancer.
To justify our position, we will show a dancer attempting to turn with her arms beginning already close to her body, then oppose it with a dancer beginning with arms outstretched and bringing them into her during the turn. As you can see, the dancer is able to complete more turns in the second demonstration. Secondly, we will show a dancer attempting to turn with her hips slightly to the right of her base of support, then oppose it with the dancer keeping her hips / center of gravity directly over her base of support. As you can see, the dancer is able to complete more turns in the second demonstration. As a novel enhancer to the pirouette, we decided to increase the change in the dancer's moment of inertia in hopes of further increasing the dancer's angular velocity. We did this by extending the dancer's radius of arms with tennis shoes and then having her bring them into her body as normal during the turn. We hypothesized that this would help the dancer to perform more turns before falling.